This is 2020-21, Chapter 10 FRQ test. Let's do this. So they're asking for the eighth derivative. Just a couple of notes as I was grading these tests. There's a difference between this and this. Parentheses here mean derivative, but here is the eighth power. Now the other option, if you want derivative, you could do the Roman numeral 8. That's also the eighth derivative. But this one is the eighth power. So be careful about how you write these. Okay, so this is the eighth derivative. Now, it'd be foolish to try to take the derivative of this 8 times, and there's a couple reasons why. But I'll get into that when I do the next problem. Any Taylor series is formed in this way. And so we get to a point where the 8th degree term has the 8th derivative. So the connection is this has to equal that, because this is how a Taylor series is formed. That is the term. Those must be equivalent. So -2 or 0.2 x minus 1 to the 8th must be equal to the 8th derivative at 1, x minus 1 to the 8th over 8 factorial. Okay? Then these will just cancel out, and you multiply both sides by 8 factorial. Those will cancel, and that's how you get the 8th derivative at 1. It'll be 8 factorial times -0.2, and that's the answer for A. Now for part B, relative max and relative min or neither, you can't do the first derivative test. It just doesn't work because of the way the Taylor polynomials are set up, okay? And so we're going to do the second derivative test. So we're not going to do the first derivative test, but the second derivative test. So how do we do that? Well, similarly, we have to find derivatives. Now, some people took the derivative and then took the second derivative. And here's the problem. If you were to say f prime of x and you take the derivative of this, you would get what? -16 x minus 1 plus 15 x minus 1 squared minus 8 x minus 1 cubed plus 6 x minus 1 to the 5th minus 1.6 x minus 1 to the 7th. That is not f prime. So this is a Taylor polynomial. It's an approximation. You would need to go forever to infinity to actually get the derivative of the function. And so we have a problem if you use this, just the 7th degree polynomial, to figure out if the derivative is positive or negative, unless you do some explaining. But if you only use a Taylor polynomial, you are not actually finding the derivative of the function at 1. So some people say, okay, so therefore f prime at 1 is -16, 1 minus 1 plus 15, 1 minus 1 squared. And you stop at the last one and not go on forever. Well, how do you know somewhere over here you're not going to get a number where it's not 0? You'd have to make the argument, okay, in this series, here's the pattern, and the rest of the terms are going to have an x minus 1 in it. Therefore, when you plug in 1, you're going to get 0. You'd have to do a lot more explaining, And you cannot just use the Taylor polynomial. You'd have to use the whole Taylor series. And the other problem is, what does the rest of the Taylor series look like? I guess you could argue they're going to have x minus 1s in it. You'd have to explain that. So that's a lot of work. And a lot of you that actually, excuse me, took derivatives did not explain that and only used the Taylor polynomial, which is an approximation to the series. So you're not getting the actual derivative. So we will go through the same process. The first derivative term looks like, you know what, I'm just going to copy it and I just want to explain this thoroughly as we go. Let me copy and paste this. So remember how the Taylor series is formed. And so if you look at this, the first derivative goes with your x minus 1 term. And if you look here, there is no x minus 1 term. Since there is no x minus 1 term, that means the derivative must be 0. So you'd have to say f prime of 1 equals 0 and give reason. Because the series does not have an x minus 1 to the first term. Okay? That means, obviously, your derivative is 0. And to find the second derivative, it comes from where? It comes from the square term. So the second derivative is in the square term. Where's the square term? It's right up there. It's negative 8 x minus 1 squared. Well, those cancel. Multiply both sides by 2. And you get negative 16. So I expected you to find the first derivative is 0, find the second derivative is 16. And since the second derivative is positive, visually it's concave up, giving you, negative 16, sorry. It's concave down, giving you relative max. Therefore, your conclusion would be f has a relative max at x equals 1, and you have to give a reason why. Because the first derivative of 1 is 0, and the second derivative of 1 is negative. So that's B. Let's keep going to part C. So most of you showed your work. There's some tricky things on here, so pay close attention to this. So g of x, and that's what we're trying to find, is the integral from 1 to x. We have to write our function, 24 minus 8, as t's. They're telling you to use t's here. So in the original, it's given as x's. You need to write it as t's here. And it says third degree. We're integrating, so that's going to increase by 1. That will be our third degree. So that's all I need. All right, now, a couple things. This is a very important step. A lot of you just did 24t, which you could. Technically, that's not right, and I'll explain that. And then 8t minus 1 cubed over 3 from 1 to x. Then you plug in x, and you'll get 24 24x minus 8 x minus 1 cubed over 3. Then you have to plug in 1. When you plug in 1, you're going to get 24 minus 8 times 0. So you get a minus 24. So what you need to do at this point, and you're going to say, how do I know to do this? And I will explain. And I think I'm positive I explained this earlier, but now it's going to be ingrained. So 24, 24, factor it out and you get x minus 1. And you might say, how do I know I'm supposed to do that? Because this is a Taylor polynomial, the form of a Taylor polynomial, x minus 1, x minus 1. You don't have just an x. That is not the form. Since it asks for a Taylor polynomial, it has to be x minus the center, x minus the center. So that is the Taylor polynomial we're looking for. Then to approximate g at 1.1, all you do is put 1.1 in for all your x's, and that's really easy. And that's your answer. Stop at this point. Now, D, the Taylor series for G, they tell you it's alternating series whose terms are decreasing magnitude 0. So to find the error, it's the next term, but to justify that, you need to explain the conditions. So you need to say g of x is an alternating series whose terms, the terms are decreasing in magnitude. So some of you are sloppy in how you describe it. You said it's alternating series, that's decreasing magnitude. The alternating series is not decreasing magnitude, the terms are. Whose terms are decreasing in magnitude to 0. So that's 1 point for giving the conditions that must be true. And the final step is the error is the next unused term. So the next unused term, unfortunately, I don't have it. I should have gotten one more after that. So I am going to backtrack and add one more here. So the next one would have been, let me go back, would have been negative 2, no, 5x minus 1 cubed. 5x minus 1 cubed. That should be t. Now, how would you have known to do that? I don't know. So if you find the antiderivative of that term, it's going to be 5x minus 1 to the 4th over 4. And you want to absolute value that. But what's your x? Your x is 1.1. And that's your answer. Oh, does it? That needs to be less than 1/5000th. Now, I'm assuming that's less than 1/5000th. I'm not going to do the calculations because that's a lot of work. But I'm pretty sure I'm good. If not, I'm in trouble. So that is part D.